Well, happy Tuesday, ladies and gentlemen, and good afternoon, or good evening, or good morning, depending when you are watching this video. But welcome to our first lecture day of at-home schooling. We are covering, as you know, Chapter 12, Stoichiometry. Stoichiometry is about to be your new favorite word, stoichiometry. I mean, just saying that is pretty cool. So, stoichiometry, and what is it? Let's go ahead and jump into that. We have a definition here. And by the way, you should be taking notes. These are the notes that you will take a picture of and you will upload as an assignment separate from your homework assignment. So make sure that you are uploading your work, and if you have not uploaded or emailed to me your homework from Friday, which were the notes on stoichiometry, I'm going to create an assignment and you can upload it there, which is easier to track than emailing it to me. Alright, so what is stoichiometry? Stoichiometry involves calculations of chemical quantities from balanced equations. Now that can seem like a mouthful, so let's take it piece by piece. Calculations, that means you're going to need your calculator in order to do this, alright? And we're looking at chemical quantities. So now we're going to take those balanced equations where we had the chemicals and we're going to put it together with the moles. You remember we've been doing moles and molar conversions. We're going to combine those things into balanced equations. So what stoichiometry does is it's a bridge for us from reactants to products, right? That is the beauty of stoichiometry. You can see there, we can start with our reactants, and it helps us to predict how many products we're going to need. Or we can go the other way around, right? We can say, I want to make this much product. How much reactant am I going to need? And this is done every day in chemical laboratories, right? They need to make a product. They need to figure out what ingredients do I start with and how much. Or, right, they have a certain amount of reactants and they wonder how much they're going to make. Just like that. So stoichiometry. Let's go to slide 2. So all we're going to do today is talk about how we interpret these chemical equations. And this is a lot like that table 12.1 that I had you copy into your notes. The reason I had you copy it, because that's what we're doing today, right? The first thing that must be done is you must balance the equation. There is no stoichiometry without a balanced equation. Impossible. Why? Because the balancing, remember, it counts all the atoms and makes sure that we follow the law of conservation of mass. What does that law say? You can probably quote it right now in front of your laptop, right? Mass is neither created nor destroyed during a chemical reaction. It is conserved. So that's what a balanced equation is going to show us. So we look here on this equation, right? And if we're balancing the equation, I'm going to pause for just a second and allow you to balance it, knowing that there's only one nitrogen involved. Go ahead and give that a shot. All right, hopefully you came up with the fact, right, that you're going to need 3 hydrogens to react with 1 nitrogen. And when 3 hydrogens react with 1 nitrogen, you're going to make 2 ammonias. Right, now the equation is balanced. Well, what does that 1, the 3, and the 2 mean? That's what we're talking about when we're talking about interpreting an equation. We're looking at these numbers and going, these are coefficients, and these coefficients give us some information. So our job is to interpret that information. The first way that we can get the information, the first way that we can interpret it is in terms of moles. We know from the last unit that that number means moles. So looking at this, I want to see you interpreting your equations on your homework today in terms of moles. That tells us that 1 mole of nitrogen is going to react with 3 moles of hydrogen and going to produce 2 moles of ammonia. Very simple. That is the first way we're going to interpret. The second way is in terms of particles. Now remember, particles are ions, atoms, molecules, and formula units. In this case, all of these are nonmetals. Nitrogen's a nonmetal, hydrogen's a nonmetal, ammonia is a nonmetal. So what we're looking at here is all molecules, but it could be ions, atoms, or formula units depending on the particular chemical formula. So we interpret it the same way. We see that one molecule of nitrogen is going to react with or need 3 molecules of hydrogen, and when they react, they will make 2 molecules of ammonia. So this is the second way that we interpret an equation. The third way is in terms of grams. Now this one requires a little bit of background work. This is where you're going to need some paper and your calculator and your periodic table in order to figure out the molar mass. When we talk about grams, we're talking about molar mass. Now if you remember, molar mass is the mass of 1 mole. So you take a look at your periodic table, go ahead for a second there and find on your periodic table, find nitrogen. Remember, anytime, if I'm going too quickly, just pause the video. The beautiful thing about technology, which you cannot do in the classroom, is you can stop me and rewind me. So hopefully you found nitrogen, and you can see that the molar mass of nitrogen by itself is 14.01 grams per mole. But notice that nitrogen is diatomic. Nitrogen always occurs with a 2. So you got to take that 14.01 and multiply it by 2. And now we have 28.02 grams of nitrogen. What about hydrogen? Looking on your periodic table, you can see that hydrogen has a molar mass of 1.01. So again, you're going to multiply it by 2. Take a second and fill out that line on your paper. You should have put 2. Oh, wait, I messed up. Miss Aguilar. Now you can laugh at me. No, I didn't mess up. What happened? Can you figure out why is it 6.06 if the molar mass of hydrogen is really 2.02? Take a second and take a look. Some of you may have figured it out. Guess what? There are 3 moles. So we're not looking at the molar mass. We're looking at the mass of 3 moles. And 2.02 times 3 is where we get 6.06 from. So when we're calculating the total mass, we have to take into account the molar mass and how many moles we have. That's where the 6.06 comes from. All right, it looks like the 34.08 already showed up on my screen here. I was hoping to let you calculate that, but don't worry. We will have more practice on the next slide. So let me get rid of my work here and think for a minute, where does the 34.08 come from? Maybe you figured it out. You took a look at ammonia and you realized that the molar mass of ammonia is 17.04. Right? 17.04 grams per mole. But how many moles of ammonia do we have? We have 2. So 17.04 times 2, that gives us the 34.08. As we're going through the lecture, if you have questions, please post them on the chat board, and as soon as I see them, I'll be sure to respond. Or, as I've already seen some classes doing, your classmates will respond to you quicker than I probably will. All right, let's keep moving forward. We'll have more practice examples. Let me erase what's up here. Okay. So, the last thing we're going to do when we interpret our equation is the law of conservation of mass. The book doesn't always ask for this last step, but I always want you to show it. The last step shows that whatever is on the reactant side has to equal what's on the product side. Why? Because the law of conservation of mass says mass is neither created, so you can't end up with more mass, and mass is neither destroyed, so you can't have less mass, but it is conserved, meaning that it must be the same before and after. So this is a super easy step. All you're going to do in this step is add up all of your masses on both sides. So in this case, when we add up our reactants, we get 34.08 grams. And in our product, well, we only have one reactant, so there's nothing to add up. We just move it down, and we get, again, 34.08 grams. And when those two numbers are equal, when our products equals our reactants, then we know we have followed the law of conservation of mass. And we can say, as we do in good chemistry fashion, cha-ching. All right, let's move on to another example. What are we doing here? 1 mole plus 3 moles equals 2 moles. Oh, we want to highlight that in our notes. Go ahead and highlight that part of the equation, because that's the mole ratio that we're going to be using on our stoichiometry chart. If you don't have your stoichiometry chart out, grab it out of your bag, and you'll take a look that there's a bridge between mole of A and mole of B. On that bridge, it says mole ratio. These are the numbers we're going to be using to do that, but not today. Today, we're just going to learn how to interpret and write mole ratios. All right, let's go ahead and take a look at our next slide. So we've already interpreted this equation on your paper. You don't have to rewrite it again. You already have it there. Well, what are we looking at? We're looking at mole ratios. How do we write these mole ratios? Well, here's our first example. We've got 1 mole of nitrogen in the equation. Notice here, 1 mole of nitrogen reacts with 3 moles of hydrogen. So we can write that as a ratio. 1 mole of nitrogen reacts with 3 moles of hydrogen. Very simple. How do you know which one to put on the bottom and which one to put on the top? Remember, we always put on the bottom the one that we are going to cancel out. That's how we decide. Whichever goes here is the one that will be canceled out. And then we can write its reciprocal. All we do is flip it upside down. What was on the bottom goes on the top. What was on the top goes on the bottom. Why? Because they're equal. So this relationship between these two reactants produces 2 options for mole ratios. Take a good look at that. Make sure you understand what just happened. All right, let's do another one. 1 mole of nitrogen this time. That's again our first relationship, 1 mole of nitrogen. You see it here also. 1 mole of nitrogen produces, oh, we're going way over here to the products, 2 moles of ammonia. So you see here on the bottom, 2 moles of ammonia, 2 moles of ammonia. Go ahead on your paper, copy that down, and write its reciprocal. Flip it over, just like we did in the first example. All right, here's what your paper should look like. 2 moles of ammonia on top and 1 mole of nitrogen on the bottom. There's one more relationship. Looking at the equation, what are 2 more things that you could relate? We've got the moles of nitrogen with the moles of hydrogen. So this one is done. We've got the moles of nitrogen with the moles of ammonia. That one is done. So what you should notice is what's not done. What's not done is the moles of hydrogen with the moles of ammonia. This relationship we haven't done a mole ratio for. So I want you to go ahead and write that mole ratio and its reciprocal on your paper, and I'll give you a minute. All right, well, hopefully what you've written down looks something like this. 3 moles of hydrogen will produce 2 moles of ammonia, and it's reciprocal. 2 moles of ammonia are made from 3 moles of hydrogen. If you did well on your paper, go ahead and make a cha-ching, and that'll tell me when I take a look at your notes that you're getting this. Let's go to our next slide. All right, here we are on a practice page. On this page, you're going to balance and interpret. This is our last example, so what I want you to do is go ahead and pause the video now, pause the movie, and balance this equation, and then you will interpret it. First in terms of moles, then in terms of particles, just like you see up here. Let me go ahead and grab the highlighter. So the first thing you're going to do is in terms of moles, and then in terms of particles, remember deciding, is it an ion, an atom, a molecule, or a formula unit, and then mass. Make sure you don't look at the answers until you've tried yourself, because you don't learn if you just see the answers. It's better for you to give it a shot, interpret all of that, and then the last statement, law of conservation of mass, you're going to make sure that your products equal your reactants. When you finish, then come back and finish watching the video, because it's going to have the answers up for you. All right, did you finish? Make sure you finished. All right, let's go ahead and go through the answers. We'll do moles first. It needed a 2 in front of the sodium hydroxide and a 2 in front of the water in order to be balanced. So hopefully you got those numbers correct. And we move on, we interpret in moles. Super easy. We just write moles in front of each of the terms. So 2 moles of sodium hydroxide. Moles, so we got moles here in front of sodium hydroxide, moles in front of sulfuric acid, produce moles in front of sodium sulfate, and moles of water. Then we add our coefficients in, 2 and 2. Remember, the ones are invisible, but you are more than welcome, right, to write them in if they're helpful to you, 1 and 1, but they are absolutely not necessary. But the 2's must be written in. Now, the second way of interpreting is in terms of particles. So what kind of particles do we have? Sodium is a metal. It is a metal. So that makes sodium hydroxide a, hopefully you said it, formula unit. Hydrogen is a nonmetal. As a nonmetal, that makes this a molecule. You can also tell because anything that starts with hydrogen, if you remember, is an acid, and acids are molecules. Again, we have sodium, which is a metal. makes sodium sulfate a formula unit. And then water. Hydrogen is a nonmetal, and so this would be a molecule. So when you're writing out your particles, it should look like this. Formula unit, molecule. Remember when you abbreviate molecule to go all the way to the C. Formula unit, and again, molecule. And once you have the right particles, then you can put your coefficients in place. So here's what we know. 2 formula units of sodium hydroxide. Right here, that's our first term. React with 1 molecule of sulfuric acid to produce 1 formula unit of sodium sulfate and 2 molecules of water. All right, the next one was mass. Now remember, mass requires some calculations. If your coefficients were wrong, your calculations aren't going to come out right. You've got to take a minute and you need to get out your periodic table and you need to add these up and multiply by 2. You need to add these up from your periodic table, the molar masses, and multiply by 1, which actually doesn't change the value at all. You need to add all the molar masses of this up, multiply by 1, which doesn't change the value, and add the molar masses of H2O and multiply by 2. Once you've done that, then you're going to be able to fill in these numbers here. All of these blanks are the totals you get from the number above it. So go ahead and pause the video now. Don't look at the answers until you've given it a shot. Right? Otherwise, you're cheating yourself out of an education. So pause the video, grab your periodic table, grab your paper, and let's do the calculations. Put the calculations on your notes so I can see that you've actually done them. Even if you do them in your calculator, you've got to make some notes about it. All right, so pause and come back when you're done. All right, if you're all done adding those up, let's go ahead and take a look how you did. Sodium hydroxide, our first one, has a molar mass of 40. 40 times 2 gives us 80. If you're wondering where did the 40 come from, the 40 comes from adding up 1 sodium, 1 oxygen, and 1 hydrogen's molar mass on the periodic table, and then multiplying by 2 gives us 80. And notice we have 0, 0. Don't just put 80. Molar mass always has 2 decimal places. If you had some trouble with that, pause the video and try the next one. Find any errors you may have made. Sulfuric acid. The molar mass for sulfuric acid is 98.09. Again, we've added 2 hydrogens, 1 sulfur, and 4 oxygens using their molar masses on the periodic table. Next, we have sodium sulfate. Sodium sulfate is the addition of 2 sodiums, 1 sulfur, and 4 oxygens. If you didn't do that, pause the video, go add it up, and come back when you have an answer. Are you ready? Here's the molar mass for sodium sulfate, 142.05. Hopefully you're going cha-ching because you got that right. And our last one for today is water. We've worked with water a lot. We know that when we add up 2 hydrogens and 1 oxygen, we get 18.02. But there's 2 molecules of water. So we got to multiply both of those by 2. And we get 18.02 times 2, which is 36.04. Now I hope you've got a big cha-ching right now and you've got all of those right. Now don't skip the last step. A lot of people can tend to skip that. Look up here. It says show the law of conservation of mass is proved. Don't skip that step even if the book doesn't remind you. That's when we add up our products and our reactants. I'm going to do some erasing here because I got a lot of writing on this screen to help us focus on what we're doing last. This is our last slide for your lecture today, so thank you for your patience, for sticking with me, and for taking good notes. So what we're doing now to do the law of conservation of mass is we're going to add these up. We're going to add up the 80 and the 98 because these are our reactants. And we're going to add up our products, 142.05 and 36.04. If we did a good job, they should be the same. So go ahead and add those up. .09 plus 80 is 178.09. 142.05 plus 36.04 is 178.09. I'm hoping there's a big smile on your face and you're going, cha-ching, because you did this right. Well done, kiddos. This is our last slide for today. We've got about just under 30 minutes. So half the time it would have taken you in class. You've got a homework assignment where you're going to practice both the mole ratios and interpreting the chemical equations. Make sure to look at your notes if you get stuck, the two examples that we did and the mole ratios. And you also have the possibility of asking questions on our team page. Don't forget to submit the homework by taking a picture of your handwritten work and uploading it onto the assignment on our team page. All right, have a great rest of your day. Stay safe, don't touch your face, and wash your hands often.